Okay, my friends, get ready for this. A bit of a shocker. This is Mikio Kaku, and apparently all the other science communicators are baffled about this force being applied from inside out of the asteroid. This 3I Atlas. They've never seen anything like it before. There's a force being applied from the inside out, like it appears to me maybe like some shooting gases or something like that. Well, let's see if we can ever find that before. Okay, my friends, then something unprecedented happened. This is Mikio Kaku, and he's talking.
3 different observatories confirmed the exact same thing. James Webb saw it, Hubble saw it, the European Space Agency Solar Orbiter saw it. 3 independent systems, 3 separate confirmations, different instruments, different angles, same result. At that point, the question wasn't if something moved inside 3I Atlas. The question became, why? And
all right, what moved inside of 3A Atlas? What did it do? How did they know that something was moving inside?
I'm going to tell you what that why might be. But first, you need to understand what happened next, because this is where it gets absolutely chilling. And Dr. Stephen Patel at NASA's Goddard Space Flight Center said something that should make every single person pause. He said, "We've seen comets tumble, we've seen asteroids break apart, but we've never seen one shift from within as if something's pushing back."
Well, wait a minute. Let's talk about that in a second. We've never seen something pushing back. Let's think about that. Think about those words.
Pushing back. Think about those words. Not reacting, not breaking, pushing, like there's intention behind it, like there's force being applied from inside out.
Well, let's see if we can find that ever happening before. Okay, so let's address the pushback issue. This is Comet 67P, just drifting through, getting closer and closer and closer to the sun. They sent a spacecraft up here. It was called a Philae lander. It landed on here, took samples, analyzed them. I have the chemistry, and they were right here, right on top of it. And guess what? This pushed back. There it is right there, pushing back. Why is it, what's squirting out of there? That's like a squirt gun. Pushing out like that is a push to this direction. You can't have a push this way without having a push this way. It just doesn't happen. And that is a huge chamber that pushed out of here because it was boiling from this interaction with the sun. The same thing that's happening with 3I Atlas. It is getting closer to the sun as it heats up. What's inside here, which is the moisture, boils out and sends out and pushes it. It's being pushed. Now don't forget, they were right here. They were right on the surface. This is right up close and personal. They took this picture. 40 meters is this wide. There's about 4 of them in here. That's about 500 feet across, was shooting out of there. Comet 67P is a very large comet, and that blast certainly was a push. I don't care how you think about it. It is a push. You can't squirt something out without pushing. It just doesn't happen. So now you say, Roger, what would push out of this thing? What's created this big hole in here, and why is something pushing out like that? Why is this happening? I can tell you why. It's because that particular comet is something similar to a hip bone. I don't know if it is an actual hip bone, but that's where it comes down, it comes across. There's a main artery that comes up, and then there's a bunch of other stuff that I'll show you in a second that is on here. It's seen, and the gases coming out of there are barbecue gases. I have the gases up here, I'll talk to you in a second. This is what we're seeing, is this ball with this shaft coming down here and broken right across here. Well, what's shooting out of there? Blood. There was blood that came up to service this muscle. And that blood has a big hole, which is basically an artery, and it's blowing out like crazy. All the other little chutes are blowing out right around here. You see these? These are little tendon fibers. And that lets the ball do a little bit of moving here and there. And the blood has to service the muscle. It's as simple as that. And there's going to be another bundle coming off of here. This is a very complicated little device, your hip. It's amazing, and it is somewhat complicated. So let's return to the emissions. This is pushing out of a 500-foot wide, and it is pushing hard. The closer it gets to the sun, the harder it pushes. Simple as that. These are those little fibers that are around all the little tendon pieces I showed you. And they're right here. Let's see, right here. You see these little straight pieces right here? Every one of those has to be serviced with a little bit of moisture, because they slide amongst themselves. When this thing moves and slides and pulls, everybody has to be free to move on their own. Same thing with the bundle of, this is muscle or tendon. I think it's tendon. Now, down here is just nothing more than dried out, ionized blood cells that are laying down here. They sort of just dried out, and deep inside of here is saturated with blood. There will be tons of blood in this. And that blood is boiling off just like it would in a microwave. When the sun hit it just right, out it boils. The closer it gets to the sun, the harder it boils. These are the little straps that are coming down, the little tendons. They need moisture too. But this baby here, that's where it's blowing out the blood. Now don't forget, I'm showing the biology here. This is biology, it's anatomy. It's simple as that. This is the chemistry. First of all, we're looking at the anatomy, yes. We're looking at something blowing out of here, out of this huge blood vessel, yes. We're seeing moisture cooking off of these little fibers that run up in here, yes. And what is coming out of there? Well, let's take a look at it. All right, here it is right here. In biology, hydrocarbons, those are CH, CH2, and CH3. They're the organic compounds composed entirely of carbon and hydrogen, CHs, serving as the basic building blocks for many other biological molecules as a primary source of stored energy. CH1, 2, and 3. And they are very combustible. They end up being methane gases. Okay, my friends, this is what they found on 67P when it got close enough to the sun and was angled just the right way and the sun hit. It boiled off these gases. Well, what are those gases? They analyzed them. All right, I understand the chemistry. This is chemistry of biology, and I contacted the European Space Agency, and they didn't disagree with this whatsoever. But they just had nothing to say about it. Now, this was from a meteorite, and its CH is burnt off. That's why they're low here. They're high up here because they didn't come through space and cook. Iron. These are the states of iron. Iron is, you breathe in and out, and as you do, the states of iron just change a smidge. You see there 56 point this, 56 down here, 58.8, 56. Right in this area is oxygen transferring through your lungs. And then you have silicon, sodium, carbon, hydrogen, all the same things that you have in the human body. And there was no question about it. The anatomy is there. The chemistry is there. It is what it is. All right, this is the email I sent to the European Space Agency. Marcus Bauer, European Space Agency International, is Comet 67P gas emissions. And this was June 2016. Hello, my friend. Great job on the comet. I am a biomolecular chemical researcher. The gases given off by 67P are organic, and they knew this. And the structure of 67P is anatomically biological as well, and anybody can see it. Amines are from meat smoke. That's what they give it. Analysis of comet 67P gases are here. All right, in the quotations I put that, because this is what they said. 6 organic compounds were identified, divided into 6 classes of organic molecules: alcohols, carbonyls, amines, nitrites, amides, and isonates. Of these, 4 organic compounds were detected for the first time on a comet. This is methylated acenate, acetone, propylaldehyde, and acetamide. So I said, I have a video on my research and I would like comments, please. Astronauts say their suits smell like steak after walks. And I included this comet video. Now this was to International Space Agency. And it was all about my research, understanding what's going on here. 56 is iron. But 56 is not all that as iron is. This is the number, the molecular number here. Hold on. All right, there's not too much to go over with the hydrocarbons. In biology, hydrocarbons, which is CH, C is carbon, H is hydrogen. Hydrocarbons are organic compounds. They come out of living things, composed entirely of carbon and hydrogen atoms. There's CH, which is just one, and then there's CH2, CH3. CH4 actually is methane gases. Anyway, they are the basic building blocks for many other biological molecules as primary source of stored energy. They're not found in large quantities as pure molecules. They're carbon-hydrogen backbones. They attach to all these other things, are the foundation of lipids, fats, waxes, and are the source of energy released when biological fuels are burned. Hydrocarbons. When you burn meat, you get polycyclic aromatic hydrocarbons. That's from burning meat, and that's what the astronauts say their spacesuits smell like when they come back from a spacewalk. Here it is right here. Don Pettit described the aroma of seared steak, hot metal, and welding fumes. When they take their helmets off, they come back in, it smells smoky because it's just saturated with cooking matter that's out there. It's just what it is. Now, again, this is nerd stuff. This is 56 stable, all right? 30 neutrons, 26 protons is what they say. Now look at what can happen. That's when it has no charges to it. It can go 1 and 2 minus this way, 3 and 2 minus that way. This is the oxygen. This is where you breathe. You add oxygen or you take oxygen away. And that can only be done with an enzyme because half-lives take forever. All right, half-lives take at minimum years. Fe60 half-life is 2.62 million years. Fe55 is 2.7 years. But and what I'm getting at is enzymes are doing these things instantaneously in your body. They can do millions of years of chemistry in under a second. That's what they're missing. You got to put all this stuff together. The enzymes, the biology, the anatomy, the chemistry, the whole shooting match ends up being biology in space. Okay, I understand chemistry, I understand biology, I understand respiration. These, Juliet and Kenneth, are the 2 molecules that they sent back the information on, the chemistry. This happens to be the Murchison meteorite that they saw hit the ground, come down and hit the ground. So they have the chemistry from this meteorite. And these are from comet 67P. Now, I'm going to show you why I say this, first of all, is biology down here, Murchison, and so is comet 67P. And as far as I can determine, every single thing that I have seen in space and that I have here in my shop, and I have several of them, are biological meteorites. And they're things in space that were body parts. Case closed. Okay, I think the story is quite obvious. They're trying to tell a likely origin story for asteroid Bennu. This is NASA. Well, I think we can come up with a likely story. Okay, this is the results of the returned sample from Bennu. Now I'm going to show you. Remember I talked about the 3 different types of blood that I'll show you in a second. Okay, this is what they came back from Bennu with. And it's a mix of life's ingredients. Well, not necessarily a mix, it's a chunk. All right, this was fabulous. They came down here onto Bennu. This is the surface of Bennu. And they blasted off a whole bunch of nitrogen, and it went way down and hit bottom and grabbed a chunk and came back to Earth with it. Now you see this very extreme red, and you see that black, it looks like the black, looks like somebody slapped it on there. It looks like it's painted onto that red. And this is probably highlighted a little bit, but these are natural colors. This thing was right here. It wasn't not right here, it was right here. So these pictures are, I would say, extremely accurate. Now let's see what else we can talk about. What did they come back? What did they pick up? They didn't just grab a chunk of this or that. They just went way down until they basically hit bottom and grabbed, came back. What did they come back with? This is what they came back with. They were freaked out when they saw what they had. They didn't know about this. They called this the phosphate surprise. These layers, you see the layers of white little stuff, and then another light layer like this, and then these blocks in between these layers. And these are the blocks. So we're going to look here. We're looking at them closer up. So these are the blocks. Now, I know what the blocks are. Those blocks are just not little chunks of things that are just laying there with phosphate layers over and top, because there's a bunch of them. It's not just 1 or 2. These are all in a similar type of situation. All of these are actually ropes. And I'll explain to you what this is all about. These are what's called sarcomeres. And I'll show you what happens with sarcomeres in a bad day. All right, before I go too far, look at this structure. The layer here, the blocks in between. This is a damaged heart. That's heart attack. But this is a standard sarcomere, should look like this. And this was what they came back from Bennu with. Basically the same thing. Well, it is the same thing. It's from a heart. I'm going to tell you right now, it's from a heart. These layers are phosphates. Phosphates are phospholipid layers. There's 2 layers. What is layer over, a layer on the top, layer on the bottom. And on every one of these layers of sarcomeres, they have to be able to do this and that. But they have to be able to pull into and twist and do all kinds of things. And that's what allows them to do that, is this phospholipid layer. It's mucus and slippery and everything, and that's how your body contorts and does all that and still can pull in. It's a very, very sophisticated device, the human body. Now, again, this is what they came back with. The same stuff. Same membranes, the same sarcomeres. Now, what did they have as far as chemistry goes? Well, they had exact same chemistry that's in us. And they're not denying that. They said they found 14 out of the 20 amino acids. They found all kinds of things in there, RNA and everything. So it's exactly like us. Or not, maybe not human-ish. I don't know what it is. I don't know what it is from. Well, it's a heart, and here it is right here. And this right here is a valve. That's a valve. There's huge valves. This is plumbing. This is squirting blood all day long. Huge valves coming out of here. Up above, and they break right off because of iron banding. And I showed you before the black and the red and the yellow. Well, that's the black opposes the red, and they just bounce apart, and the whole top pops off of the hearts. And that just happens. And this is the iron banding. You see this? That would just fall right off of there if it had someplace to go. They don't want to touch each other. And it broke off. The whole plumbing pops right off. And we see this all the time in the mud fossils. You see over here? Same stuff. The black works with the yellow because it's transferring oxygen, but it will not work with the red. It has to do a transfer. That's why we see this, and that's why the hearts pop apart. And when they do pop apart, we can see down in the valves. Right here. They pop apart right along there. There's a line right across there. There's a red and well, hold on. You see all the valves and plumbing that's on the top? With that red and that blue, in the mud fossils, it's black. And anytime it gets exposed to oxygen over the course of time, it just turns black. Now, the red stays red, and the black opposes the red, and they just pop. The whole thing just pops right out. I mean, literally pops off. And I've talked to people that do autopsies, and they say, yeah, cadavers that are around for a while, the top pops right off, basically off the heart. And what you end up with is being able to see down into the valves. So here, this just pops off because of those red and black. Pops off. And I think it goes like, I don't know if that actually happens, but it's gone. And what you can see down is this, which are the valves. Like I showed you, a lot of plumbing. This is Psyche, which is another heart in space. I'm telling you. They're out there. Now, this is the actual Bennu that they landed on. Don't forget, they blew all the stuff away and went down, grabbed a chunk of muscle, came back to Earth with it. And here it is right here, is the sarcomeres. And again, it has all the chemistry and all of the biology, amino acids, everything. So they say, well, maybe it brought life to Earth. No, that is a heart from gigantic battles in space or something. Because if you look at what Psyche is, which is another heart, it has tubes coming out of it. Now, this is why they think I'm crazy, because I'm pointing out things that are factual, and there's no explanation for them other than my explanation. That is a tube. That's a tube. That's not an impact crater. That's a tube coming out. These different colors, hold on, are the colors of blood. You see the black, the yellow, and the red? Same stuff. And they're going out there because they think they can mine this because it's got a ton of metals in it. Well, blood is really saturated with metals. The transition metals that are in blood are these right here. And you see this? That's a tube coming out. That's a tube coming out. That's another tube area. You see the difference in color right here? This isn't because of some impact or whatnot. These are not craters. These are valves. This is tendon. That locks the muscle, which is 99% of the heart is muscle. It locks it above here and locks it in. And these are the three colors of the blood. The red, the yellow, and the black. You see the black over here? And they stay away from each other. They just don't like each other. It's a polarity thing. Now, these are the transition metals that are in blood. These get carried all around your body continuously, 24 hours a day. And the metal core has charges on it. And those charges attract other molecules that are dropped off here and there in the body, and then these things come back and get replenished. And they're the ligands, and they're attached by these electrons are arranged around a nucleus. You don't have to know about this. All you have to know is that there's a ton of these metals in blood. And I can show that from an opal heart. Opals are made from all these different colors. And those colors are from blood. All the different metals have a different sort of a tinge to them. Now, you know what? I'm going to just show you something. Hold on. You see this? Mud fossils come in a ton of different ways. This could be just as colorful as that. If it was, this is a bone, the head of a bone. I think it's one that goes into like your wrist, that type of thing. All right, another bone attaches right to there. There's a ligament that comes across. Now, if this died and was boiled completely out to its structural components, it's really collagens and keratins, the strength part of it. Everything else was boiled out, and it was in where there was blood. All that blood would come in, and it would make it into opal. And that's what happened in Australia. It looks to me like there was areas that were just completely boiled out, completely, totally, and there's so much blood in Australia, it's just as red can be. The blood came back, and every one of those blood, all those metals have a different charge to them. So the one has, like, say, a charge of +3, found this, which is the ventricle wall, and attached. That's why the whole ventricle wall is like that. And of course, the red blood is, without any metals in it, is just plasma, like this here. And that's why I know it died laying like this. This was been down. Metals are heavier than the plasma. All these different metals found a place where they could attach to something that they felt comfortable with. All right, so that's what happened there. And that's all these transition metals right here. These charges mean I want to go to attach to something. Now, normally they go through your body and they say, do you need any of this? And they say, yeah, give me 2 of those and I'll give you 3 of these, and back and forth. And that's how they worked. Now they come out and they say, hey, can you guys work with me? I say, no, we're done. So it says, well, who can I hang out with to be, and they say, okay, go to the ventricle wall. This color here, go over to the ventricle wall. And that color goes to the ventricle wall. And another one comes in, it says, go up to this membrane. Another one comes in, it says, go to that membrane. It's just, that's the way opals work. They're biological. And that right there is the same as this right here. There's the ventricle walls. The heartstrings are in there. And they break right along there. All that plumbing goes away, and you can see down. And you can see it's the same as this. Now, let's go a little deeper. Okay, as far as Bennu goes, I mean, it's right here. It's got the chemistry. This is a heart, and this is the sarcomeres. I'm going to get rid of that one now. This is from Bennu. These are the sarcomeres. These are the phosphate surprise layers, which they have no idea why they're here. They're there because they're membranes. So we're going to get rid of that one. This is what sarcomeres are. Exactly what I showed you. This is the biology. I'm going to get rid of that one. Now we're going to go to something else. Okay, now Avi Loeb claimed this space thing, whatever it was, a comet, asteroid, whatever you want to call it, is called a Mau Mau, and he said it could be a rocket ship or a spaceship or some alien spacecraft. Well, it's actually a finger, and it's all the way from the knuckle, which is right here, all the way up to the grip skin tip. And when I say grip skin tip, there's a heavy duty skin on your fingers that covers them, and it peels right off. Now, this white strip here, let me turn the lights off. Sometimes this gets better. Now, let's take a look at this. This, from here down, this white strip is a tendon. And it anchors, well, it's actually the bone and tendon, but the tendon rides over it. It anchors right there. That's the knuckle, the little, right here, that's on you, right there. All right, now, what happens is, and then there's, of course, it keeps going down this way. This is what happens with the bones. Right at the anchor, I mean at the joint, where it would flex, you got all these little anchors going into these holes, and they get collected in the back, locked in. And then you got another one over here, and this is a Mau Mau. Now, I had an anatomist, one of the best in the world. Of course, I don't want to use anybody's name, but I had him look at it, and he says, yes, in his opinion, it is a finger. Now, this is the tendon. I'm going to show you some anatomical stuff. And it keeps going down here. The black, and over there would have been red, but black is from the vein blood. And down here, you got tendons running across the top. So the other side is where the fingernail is. This is the bottom side where the grip, this is called grip skin. So we've got a piece coming down like this of tendon, anchors into here. We've got another one coming up that anchors into here. So this can do this right at that spot. And then it all comes down right down to the knuckle. It's just ripped right out of there. Boom. Now, let's look at this grip skin. Remember I said there's grip skin? You see that little place where it's ripped off in the front there? You see? It's like painted on there. And you see that little, this right here? That is an apical tuft, and I have one here that I can show you. And all of the little balls lock into that apical tuft. I have one here that's completely eroded out. This is it right here. That's what they look like. They have these little balls in them. They're all over the place, and they lock in from that tendon. The stuff I have is huge. And this is no question. I have stuff that's DNA tested, CAT scanned, the whole 9 yards. So it's time to take this seriously. And this is a body part in space They said there was battles in the heavens. I didn't make that up. Every culture on Earth had the same stories. And we laughed at them all, which I don't think it's the time to laugh anymore. Okay, so getting back to where we started, yes, we know things push out here when they get close enough to the sun for the sun to cook them and make them push. Now, if that was just sort of twisting, it pulsed and pulsed and pulsed, maybe that's what they're talking about. I have no idea, but I can tell you what, this is no question. If you're squirting out whatever it's squirting out of there, which is polycyclic aromatic hydrocarbons, which is meat smoke, it's pushing this way. There's just no other possibility. You can't push that way and have no effect this way. It just doesn't happen. In space, you push this way, equal and opposite. Equal and opposite. So here's another one of my specimens, and this was DNA tested. This is the grip skin, and it's actually still got fingerprints in it. You see it, the sweat pores? The fingernail was up here. And it's 3 feet long from here to the very, very front. This is the grip skin I was talking about, that Avi Loeb on his Omao. Now, I had to break this off to get down to get into the DNA, which I did, into the blood, which I did. And it's dried out. It's not wet, usually. Sometimes it is. And I took it out of there, and of course, I did it very, very carefully, clean and all that, and it was excellent quality, dense, and it was human mitochondrial DNA. I don't know, mitochondrial means we all came from the same mother. And everybody has basically that same mitochondrial DNA, is the way I understand it. And it's Homo sapien. Now, we got push to shove. No question, you push and shoves. So we have seen this before. So what they were talking about, Mikio Kaku, is not correct. We've seen it before, and we've seen biology everywhere. And to have this sample back here on Earth for a couple of years and not be able to deal with what we have in our own hands doesn't say much for science. So I guess I'm going to leave it at that. But, we're taxpayers. We're paying a lot of money for this, well over $1 billion, and they have this for 2 years, and they're going to study and study and study. And I know we're spending a ton more money to study something that I would like to be involved in the study, because you can't miss it if you have enough people that, a mixed background of people. You have to have an anatomist, because you can't miss the anatomy. I mean, not a single thing here can be missed. Everything was here. Anyway, I'm going to leave it at that. We have seen push, shove. I would like to see everything they can present for 3I Atlas. But I haven't seen a lot, to be perfectly honest with you. And even the colors, I can talk about that too, because the colors are here. These colors are represented by different metals and minerals. And they cook off at different temperatures. It's very, very simple, basically. All right, I'm going to leave it at that. Thank you. I love you all.